Hello guys, and welcome to this video. So I'm going to be introducing you to using Laplace transform method to solve initial value problems for constant, coefficient, linear and homogeneous, non-homogeneous differential equations or homogeneous differential equations. So for this problem, if you were given a question like this, how are you going to solve it? The set solve the initial value problem. D squared y by dt squared plus 2 dy dt plus 5y equal to exponential minus t sine t. So with Laplace transform, and given that you have these initial conditions, y of 0 is 0 and y prime of 0 is 1. So this is how I was going to do it if it were me. So d squared y over dt squared plus 2 dy over dt plus 5y equal to exponential minus t sine t. So I'm going to take the Laplace transform. So if I'm given this, I'll take the Laplace transform of both sides. So if I take the Laplace transform of both sides, I'll have Laplace transform of d squared y over dt squared plus 2 dy over dt plus 5y is equal to Laplace transform of exponential minus t sine t. Now, if you evaluate the Laplace transform of derivatives, you are going to find out that for the second derivative, we have s squared y of s minus s y of 0 minus we have y prime of 0. Okay, then you have plus 2, open a big bracket, then evaluate the Laplace transform of dy dt. You're going to get s squared, not s squared, but since it's the first derivative, you have s y of s minus y of 0, then plus 5. Then the Laplace transform of y is capital letter Y of s. Meanwhile, the Laplace transform of exponential minus t sine t by the first shift theorem is going to give me 1 all over, I will have s plus 1 all squared, then plus 1, like this. So we can now apply initial condition. Y of 0 equal to 0 and y prime of 0 equal to 1. So this term is cancelling out because of y of 0. This term is cancelling out because of y of 0. So the only term that will survive is this y of 1, which is 1. So you have s squared y of s minus 1. And you now have plus 2s y of s and plus 5y of s is equal to 1 all over s plus 1 all squared plus 1. Is that okay? So if you're wondering how I got this, I don't want you to be afraid. I will create a video later that shows you how to find the Laplace transform for this kind of functions, and you have to use a theory called first shift theory. Okay, so in this place we'll have s squared y of s plus 2s y of s plus 5y of s and minus 1 is equal to 1 over s plus 1 all squared plus 1. So factoring out y of s, you have s squared plus 2s plus 5, and this becomes equal to 1 over s plus 1 all squared plus 1, and this is plus 1, like this. So the aim is to make y of s the surrogate of the formula. Y of s is called the transfer function. Okay, take notes. So you have s squared plus 2s plus 5. So if we solve this, we're going to have 1 all over s plus 1 all squared plus 1. Then plus you have s plus 1 all squared plus 1, like this. Okay, so this is what you will have when you solve this. So you have y of s into s squared plus 2s plus 5 gives us, I have 2 plus s plus 1 all squared all over s plus 1 all squared plus 1. Okay, so my y of s is now 2 plus s plus 1 all squared all over s squared plus 2s plus 5 multiplied by s plus 1 all squared plus 1, like this. Okay, so this is our transfer function. So you can still simplify the transfer function. 2 plus s plus 1 all squared all over, you have s squared plus 2s plus 5. Then when you simplify this one, I'm having an s squared plus a 2s plus 1 plus 1, which is plus 2. Is that okay? Then you have your transfer function in this form. So the next thing is you need to find yt, and y of t is the inverse Laplace transform of our transfer function y of s, which is the Laplace inverse of 2 plus s plus 1 all squared divided by s squared plus 2s plus 5, s squared plus 2s plus 2. Then if you have it in this way, the next thing that you need to do is you need to consider this fraction over here, 2 plus s plus 1 all squared all over s squared plus 2s plus 5. Then you have s squared plus 2s plus 2. So this is equivalent to as plus b all over, okay, s squared plus 2s plus 5. Then you now have plus cs plus d all over s squared plus 2s plus 2. Is that okay? So this is what it is like when you split it into partial fractions, because you actually in this case have you have the denominator consisting of the product of two quadratic functions. So you have it in this form. So our objective is to find the value of a, b, c, and d. So this is how we are going to do it. If you multiply through by this term over here, you're going to have 2 plus s plus 1 all squared is equal to, you have as plus b into, so multiplying, you're going to have what? S squared plus 2s plus 2. Okay, then plus cs plus d. When you multiply this by this will cancel out and you'll be left with s squared plus 2s plus 5. So our objective is now to find the value of what? A, b, c, and d. And we're going to do that by comparing coefficients. Now, there are different ways of comparing coefficients. Someone can decide to open all these things, then you now collect all the terms together, all the terms in s squared, all the terms in s cubed, s, and all the constants term. But trust me, I'm not really going to follow that approach, okay, because I believe it may waste time. So what I'm just going to do is I'll expand only the left-hand side. Expanding only the left-hand side gives you s squared plus 2s plus 3. When you expand the left-hand side, then it's equal to as plus b, and you now have s squared plus 2s plus 2, then you now have plus cs plus d, then you now have what? S squared plus 2s plus 5. So the first thing we are going to look at is terms in s cube. Now from the right-hand side, you have to be very careful here on the right-hand side. When you're considering terms in s cube, terms in s cube. So what are the terms from the right hand side that can contribute s cube? So as multiplying this one will give you as cube, right? Cs multiplying this one gives you cs cube. That is all. So in the right hand side, the sum of terms in s cube is actually a plus c, and on the left hand side there is no s cube. I can say 0s cube plus. Is that okay? So a and c on the right hand side is equal to 0. So when you compare coefficients, so this approach of comparing coefficients, I call it leap of faith. Leap of faith, because it involves you observing. You have to be careful. You don't have to open the brackets. You just have to observe and collect your terms. So if you can follow me carefully, you will see how I'm going to do it and we'll get our answer. So this is equation 1, from which a becomes minus c, or c becomes minus a. A plus c equal to 0 implies a equal to minus c, or c equal to minus a. So the next thing we are going to go to is what? Terms in what? let's look at terms in s squared. So let's look at the terms in s squared. So you ask yourself, on the right hand side, what are the things that can contribute s squared? The things that can contribute for s squared. So as and this gives me an as cube, but as and this will give me what? 2as squared. So I'll just be writing, permits me to discard the s square. I'm just going to write only the 2a. So you have 2a from this place. Then I think that is all. Then in b now, when you start using b to open the brackets, b times this will give you what? A 2bs squared. So you have 2a plus b in this case. Are we good? Yes. So 2a plus b. Then these are the terms that contribute to s squared from these brackets. Then let's go to this bracket. The same thing happens when you use this one to open this one. You're going to get 2cs squared. So you have plus 2c. Then you now have finally plus d times this term gives you an s squared. So you have d. Is that okay? So the contributions of s squared on the right hand side is all these terms that will contribute to s squared. While on the left hand side, the only coefficient for s squared is 1. Okay, now you should remember that a is equal to negative c. Is that okay? So you have that this equation will reduce to what? 2 into minus a. Sorry, a is equal to minus c, or c is equal to minus a. Let me use this one. So I have 2a plus b plus, instead of 2c, I'll have 2 into minus a and plus d. So if you solve, you will have plus 2a minus 2a cancels out. So simply put, 1 is equal to what? B plus d. So this is equation 2. So we're going to save equation 2, okay, for later. Then let's move forward. So I want to copy this because I'm going to need it. So it's kind of like cropped too much, but I think I can still complete it. So this is is an s plus 2s and plus 3. So I have as, bs. These are 2s plus 5. Is that okay? So we should take note of this. So we want to look at terms in s. So let's look at the terms in s now. Or yes, we can look at the terms in s. So for our terms in s now, follow me carefully. On the left hand side, the only contribution is 2. So 2 is equal to, on the right hand side, as into this one is higher, as into this one is a square, then as into this one gives me 2a, okay, for s. Then b cannot go into this one because it will be s squared, then b into this one is going to give me 2b. Okay, we are looking at the terms in s. So 2a plus 2b from this bracket. Then we now have plus. For this bracket, you know it's definitely the interaction between this and this one. So you have 5c, okay, and you now have plus finally d times this second term. So take note, there's a square here, okay. So d times this is a d squared, d times this is a ds. So you have 2d. Is that okay? So we can rewrite this equation as equation 3. Let's just keep it somewhere at this point. I'm not going to use it now. So terms in constant term. So the constant term now. So for the constant term, I have 3 on the left hand side. So 3 is equal to. So having 3 on the left hand side, how am I having a feeling that we should just go through the terms in s again? So for the terms in s, I have 2 here. Then for a, as times this term over here will give me my 2a. Is that okay? Then my b is b times this second term, which will give me my 2b. Then for c, you have c times this last term, giving you 5c. Then you now have what? D times this second term, giving you 2d. Okay, so for the constant term now, we have 3 as the constant here. So the only term that yields a constant is actually what? 2b from this bracket. 2b bracket. Every other one will have something to do with s. So I have 2b a s square s cube s square s, then s square s, then constant. The same thing happens here, s cube, here s square, here s, then here is s squared, and here is what? S, then here is constant. So 2b plus 5b is my constant term in this case. So this is equation 4. Now, if you remember in equation, one of our equations, I got a relationship between b and d, right? Now 1 is equal to b plus this. So let's apply it and solve the simultaneous equation. So you have 1 is equal to what? B plus d from equation. This was equation about 2, right? Recall. So you have 3 is equal to 2b plus 5d. So this is equation 4. So we are going to solve it simultaneously to obtain the value of b and d. So b is equal to delta b over delta naught. I hope you are going to appreciate this method, and d is equal to delta d over delta naught. Now, how do I get my delta b? Delta b is very easy to get. It's a determinant that comprises of, instead of you to put the coefficients of b, which is 1 and 2 here, you're going to skip this coefficient of b and replace it with 1 and 3. And you leave d the way it is. D is 1 and 5. Then that is your delta b. Then to get delta naught is all these coefficients here. Okay, so this is from Cramer's rule. So you have 1, 2, 1, 5. So this will give me the value for b. And this is going to be 1 times 5 is 5 minus 3 times 1 is 3 all over 1 times 5 is 5 minus 2 times 1 is 2. So this is a 2 over 3, okay, for the value of b. Then how do I get my d? Then to get d is equal to what? Delta d over delta naught. So let's find our delta d, and let's assume our delta naught is still equal to 1, 1, 2, 5. We are not assuming, we know that our delta naught is the same, okay? So this is how you find it. So to get your delta d, you're replacing the coefficients of d here with this, you understand, constant term. So that's the concept. To get the delta of any particular term, you replace their coefficients with the constant term and you retain the position exactly. So my b stays as 1 and 2 if I'm not mistaken. Okay, b stays as 1 and 2. Then instead of me to put 1 and 5, I'll replace it with what? 1 and 3. 1 and 3. So the concept is what? To use the constants. For delta b, we replaced the coefficients of b with the constants, and for delta d, we replace the coefficients of d with the constants. So delta naught is, you're not replacing anything, you leave it like that. So if you solve this, you get what? You get 3 minus 2 divided by 5 minus 2, which is a 1 over 3. So our b is 2 over 3 and our d is what? 1 over 3. Is that okay? So we have gotten the values of b and d. So we can now apply these values to get the value of a and c. So let me copy out equation 3, okay, so that we can now find the values of a and c. So Control C. So Control V. So this is our equation 3. So you now say recall from equation 3 and equation 1, we got our a plus c is equal to 0, or a is equal to minus c, or c is equal to minus a. We have already gotten b to be 2 over 3 and d to be what? 1 over 3 from what we solved up here. So what we are going to do is we are going to substitute all this stuff. Let's say we replace c with minus a. So you have 2 is equal to 2a plus 2b, that's 2 into 2 over 3, and plus 5c, that's 5 into minus a, and plus 2d, 2 into 1 over 3. Okay, so at the end of the day, 2 is equal to what? 2a, then you now have minus 5a, then you now have plus 4 over 3, then you now have plus what? 2 over 3. So you have 2 is equal to negative 3a, and you now have plus 4 over 2 plus 4 over 3 plus 2 over 3 is 2, because 4 plus 2 is 6, and 6 divided by 3 is 2. So 2 cancels out 2. Then you find out that a is equal to 0 over minus 3, which is equal to 0, and equal to minus c, and it implies that c is also equal to 0. Therefore, a is equal to minus c, and both of them are 0. That means our partial fraction will only return the value for b as 2 over 3 and d as 1 over 3. So we've gotten the value of our partial fraction. B is 2 over 3 and d is 1 over 3. So let me just copy this one. Okay, so copying this and pasting it over here. Okay, so you have it like this over here. So therefore we have 2 plus s plus 1 all squared divided by s squared plus 2s plus 5 into s squared plus 2s plus 2. It reduces to the value of b is 2 over 3, and you now have s squared plus 2s plus 5, and you now have plus d is 1 over 3, then you now have s squared plus 2s plus 2. Is that okay? So we are now saying that the Laplace inverse, sorry, let me be more professional, plus 2, that our y of t is the Laplace inverse of this stuff, which is the Laplace inverse of 2 over 3 into s squared plus 2s plus 5, okay, then plus 1 over 3 into s squared plus 2s plus 2, like this. So I'm going to copy this one so that we can solve it on a new line and run out of space. So this is where we are now. So we want to round up our problem. So we now distribute the Laplace inverse because it also obeys the property of linearity. So you now have Laplace inverse of 2 over 3 divided by s squared plus 2s plus 5 plus Laplace inverse of 1 over 3, sorry, I'm rushing, s squared plus 2s plus 2. Okay, so also principle of linearity, this will be 2 over 3 Laplace inverse of 1 over s squared plus 2s plus 5, and plus 1 over 3 Laplace inverse of 1 over s squared plus 2s plus 2. Okay, so the next thing is, how do we go from here? So follow me. So you have 2 over 3, and if you want to solve this one, first of all, you do Laplace inverse of, to solve this one, we'll have to complete the square. Okay, we'll complete the square in this fashion. So completing the square, I have s squared plus 2s, okay, plus 1. S squared plus 2s plus 1 is a perfect square. So 1, because this one was not here before, so to make these two equations balance, I have to make here 4. So this is 1 like this. Then I'll leave this one in this way, then plus 1 over 3 Laplace inverse of 1 all over. So this one, the same thing will happen. You have s squared plus 2s plus 1 plus 1. So since s squared plus 2s plus 1 is a perfect factor, perfect square, so that's why I splitted it in this form. Then that's 1. This one you're seeing here is so that when you do 1 plus 1, you get back 2. And this 4 you're seeing here is so that when you do 4 plus 1, you get back 5. So when you do it like this, you have y of t is 2 over 3 Laplace inverse of 1 all over. This now becomes s plus 1 all squared, and plus 4. You can take 4 as 2 squared. Is that okay? then you have plus 1 over 3 Laplace inverse of, you have 1 all over s plus 1 squared, and this one over here you can take it as 1 squared. Okay, so s plus 1 is this value that you're seeing here. So take note, s plus 1 all squared is s squared plus 2s plus 1. So at the end of the day, so what I can now see is 2 over 3 Laplace inverse of, now this one looks like a form that I know, so I'm just going to do a 2 here and a 1 over 2 here, like this, divided by s plus 1 all squared, then plus 2 squared, then plus 1 over 3 Laplace inverse of 1 all over s plus 1 squared plus 1 squared. Okay, so the reason why I introduced this 2 here was because there was a 2 here. So I introduced these 2 and I introduced the reciprocal over here so that I can cancel the effect of introducing it at first. So this reciprocal that I introduced here will now cancel out this one. So you have your y of t will be 1 over 3. Then the Laplace inverse of this whole stuff, okay, the Laplace inverse of this whole stuff is going to be what? Who can guess what it will be? So I'll use shift theorem, and using shift theorem is going to be exponential minus t sine 2t, okay, exponential minus t sine 2t, and plus 1 over 3. And for this one, if I use shift theorem, it will be exponential minus t, and you now have sine t. Is that okay? So at the end of the day, our y of t is exponential minus t over 3 into what? Sine 2t plus sine t, like this. So you can leave your answer like this, or if you want to go further, you can use that sine A plus sine B, still the same thing as what? 2 okay, so this is a formula that you can use if at all you remember it. So you can actually leave your answer here, but I just want to be fancy a little. So my y of t is exponential minus t over 3, and into, I have 2 sine, so here is a and here is b, right? So a plus b all over 2, that's 2 plus 2t plus t all over 2, then you now have cos, I have 2t minus t all over 2. So your y of t is exponential minus t over 3, then you now have 2 sine, 2t plus t is 3t over 2, so you have 3 over 2t, then you now have cos, 2t minus t is 1 over 2, so you now have t over 2, which is still 2 over 3 exponential minus t, and you now have what? Sine 3 over 2t cos t over 2. So that's it. So this is the answer to our question, answer to